Hello dear students, now we will discuss about the energy of the satellite. In previous classes we have discussed what is satellite, what are the types of satellites, how the satellite will be launching, how many methods we are using to launch the satellite, that is two-stage rocket. These are all things we have studied. Now let us study about what will be the energy of the satellite. Actually, what is satellite? Satellite is one object which is revolving around the earth in a uniform circular motion. So let us study with the diagram here. So as you know here, in previous classes we have considered this is the satellite. Yes, it will take a uniform circular motion around the earth here, right? So what is this? Radius of the earth, whose mass is capital M, will be a certain height above. Above means above the surface of the earth, right? Totally radius of the orbit. So this is nothing but the orbit here. Uniform circular motion done by the satellite, right? So uniform circular motion of the satellite is taking place around the surface of the earth, but it is not attached to the earth. It will be above the surface of the earth. That also we have discussed. Now to do this revolution around the earth, it has some energy, then only it is possible to revolve around the earth or any kind of object. The object is revolving around the planet. If satellite is what? It is a one object which is taking revolution around the planet. Now planet we have considered here earth, and then we have considered here satellite. It is showing the circular uniform motion around the earth means it has some energy. So what is that? That only we are going to discuss here. Now let us concentrate here. If satellite is showing the circular motion around the surface of the earth, or the uniform circular motion around the earth, this is possible. Means it has a one motion. It means it has a motion. Due to this motion or due to this circular motion around the earth, it will give the kinetic energy. So kinetic energy means what? Due to work it is. Due to work we will get. How much work you are doing, that much energy you are having, right? That is nothing but if satellite is executing the uniform circular motion around the earth, means it has a energy. What kind of energy it is? It is a kinetic energy. So satellite has a kinetic energy due to the motion, or else we can say that it is due to motion of the satellite. Motion of the satellite. Motion of satellite here, right? Now, if it is having kinetic energy due to its motion, right? How we are getting? Due to the motion of the satellite, we got it. Then it should have a storage energy also. No? If the body is showing function means before showing the work or before coming into the action, so there earlier it will be in the rest. That means the energy it is stored. Storage is nothing but the potential energy. Before doing any function, or if a satellite is moving around the earth in a uniform circular motion, that is nothing but the kinetic energy, right? If it is showing such kind of energy means there must be some storage energy, right? That is nothing but the potential energy. Potential energy means it is always storage energy of the object or a material, right? So how potential energy will be gained by the satellite? Satellite will gain the storage energy due to the gravitational force acting on the satellite by the earth here. Clear? How the kinetic energy getting for the satellite? Due to its own motion around the earth, uniform circular motion, it is doing the revolution around the or revolving around the earth means it is getting the kinetic energy. So kinetic energy of the satellite is due to the motion, its own motion. Then potential energy for the satellite, it is due to the gravitational force which is acting on a satellite by the earth it is. So what is that gravitational force? F is equal to G capital M small m by R square, right? So that is potential energy of the satellite. executes both kinetic energy and potential energy, then both the energy will be called as the total energy of the object. Right? So how we are getting the kinetic energy for satellite here? Satellite executes the circular uniform motion around the earth. Due to this functionality, kinetic energy will be there for satellite. So satellite having the kinetic energy due to its own motion around the earth. Then what about the potential energy? It is having potential energy, means it is the storage energy. How we are getting for the potential energy for satellite? That is due to the gravitational force which is acting on the satellite there by the earth. So which is predicted by Newton's law of gravitational force. What is that? Gmm by r square, the product of two masses and square of inversely proportional to the square of the distance between them. Now here r is what? That is nothing but the radius of the orbit here. Capital R is what? That is the radius of the earth. Right? Now what about the total energy here? Total energy of the satellite. Total energy is what? Sum of kinetic energy and potential energy. So what is this kinetic energy here? Kinetic energy, how we will write? General kinetic energy is what? Half mv square. Right? Now what about the kinetic energy here? This. Half mv square and g capital N small m by r square. Is it true? No. It is not true. Why? Means kinetic energy due to its work, motion of the satellite I said. Potential energy is what? Due to the gravitational force which is acting on the satellite by the earth here. But this kinetic energy of the satellite is balanced by which force it is? Gravitational force which is acting on the body by the earth. It is nothing but the centripetal force. So what is that? The body which is showing the revolution around the earth means it is balanced or it is concentrated towards the center of the earth. So one thing you should remember here, both the kinetic energy as well as the potential energy is due to this earth only. Kinetic energy means what? The body which is executing the motion around the earth. Right? But it is balanced by the center of the earth. That's why it is called as a centripetal force. So required centripetal force is needed for the satellite to revolve around the earth. It is. So how much centripetal force is required to do the revolution around the earth or revolving around the earth? That is balanced here. Means it is provided by gravitational force of attraction which is acting on the body by the earth. So centripetal force, this is attracting towards the center of the earth. Kinetic energy, right? Kinetic energy of the satellite is due to its motion, right? But it is balanced by or it is concentrated by centripetal force. So what is centripetal force here? Centripetal force means what? It is attracting towards the centripetal force. That is mv0 square by r it is. So v0 means what here? Orbital velocity. We will take it. Right? Now, what is the centripetal force here? mv0 square by r. Now, that is centripetal force is balanced by gravitational force here. What is centripetal force here? mv0 square by r here. That is equal to g capital N small m by r square here. Right? Clear? Got the point? Now, what will be the next point here? Once we have compared centripetal force which is required by the satellite to revolve around the earth, that is balanced or that is centripetal force. How much it is required? That is provided by the gravitational force which is acting on the satellite by its earth only. Now what it will happen? Let us consider this is the equation 1. Now what is the final point? r square is equal to g small m by r. Can I write it? So r will get 1 will cancel and remains with this one. Let me consider Dividing this equation, dividing equation 2 by 2, right? Let me check here. So let me divide 1 by 2 mv0 square divided by gmn by 2r, right? Clear? So why I am dividing here? It should be equivalent to the kinetic energy of the body. What is kinetic energy? Half mv square, whatever may be the object. The body which is showing the work means it is having the kinetic energy. Then is it equivalent to the kinetic energy which is responsible for the satellite to revolve around the earth, which is nothing but the centripetal force, which is provided by again gravitational force which is acting on the satellite by its earth or by the earth. What is gravitational force? Gmn by r. If you divide this equation by 2, you will get half mv0 square, that is equal to gmn by 2r, because we are dividing by 2 on both the sides, LHS and RHS. Now concentrate here this part. Is it equivalent to your kinetic energy of the body? Yes, half mv square. So directly I will write it here. Ke is equal to gravitational force, that is gmn by 2r here. So this is the kinetic energy of the satellite. What is this? Kinetic energy of the satellite. Now we got the kinetic energy of the satellite. Now we will move towards the, what will be the potential energy of the satellite. Once we got the potential energy, we can able to find the total energy of the satellite. Now what will be the potential energy here? Directly you can go for the previous classes. You will get here u is equal to minus g capital M small m by r. So you will get it in here. This will be minus, right? Minus gmn by r. So as we discussed in the previous class, total amount of work done in bringing the gravitational potential, total work done in bringing the body or a point mass from the range of infinity to the particular range, gravitational field range. How much work it is done, that much work is equal to the potential energy. Sirs, we have discussed those things. We have discussed. Those who have not understood clearly, you can go to the previous class, then clarify, and now you will, at that time you will get the clarification. So here I can't again express the potential energy, because it's the same concept we have discussed. Gravitational potential energy, intensity of gravitational field. These all things we have already discussed. From that we can recognize here. Even though I am just giving the clarity how we got minus gmn by r. This is nothing but the amount of work done in bringing the body which is away from the gravitational field, that we are bringing to the particular point where the gravitational field is there. There potential will be executing, or field, that is force of attraction, gravitational force of attraction takes place between the earth and the body. So that is potential energy, that is equal to the potential energy. Storage energy will take it to the action here, that is equal to gmn by r here, right? Once we got the kinetic energy and the potential energy, now we can find here total energy, right? Total energy means what here? Kinetic energy plus potential energy. What we have kinetic energy here of a satellite? I will write it here. Total energy, right? Satellite. Okay, satellite. That is gmn by 2r minus of gmn small m by r. So that is equal to G capital M small m by r. Here negative sign will come. Don't apply your mathematics from here. It is bigger minus smaller, that is equal to positive only. No. In physics, negative sign means there is a very important role. Why it is negative sign? Gravitational force is attractive force in a nature. So negative sign indicates here satellite is always bond with the earth. Means gravitational force which is acting on the satellite by the earth does. That's why negative sign comes here. What is the total minus gm small m by r dash. Right? That is equal to, you can write it here, minus g small m capital M by r. This will give you the energy of the satellite. This conclusion we can say that satellite has its kinetic energy and potential energy. Kinetic energy due to its motion around the earth, that is provided or that is balanced by centripetal force, which is required centripetal force which has to do a revolving around the earth, that is potential energy, and the that is kinetic energy. Potential energy means what? That is the storage energy of the body, that is provided by the gravitational force which is acting on the body by the earth. This is about the energy of the satellite. We will discuss about the time period of the satellite. Time period of the satellite. Time period of the satellite. Now, just now we have discussed about the energy of the satellite. Right? What is that? Total energy of the satellite. Sum of kinetic energy and the potential energy of the satellite will give the total energy of the satellite. It has an energy that will shows revolving around the earth in a uniform circular motion. Yes. Now let us move towards the how much time it will take to complete one revolution around the earth. Now let us consider here the satellite which is revolving around the earth in a uniform circular motion here with the velocity, orbital velocity v0 here, and above from the surface of the earth, that is height h, r is the radius of the earth, and let m be the capital M be the mass of the earth, small r that is equal to the orbital radius or radius of the orbit. So that is considered here orbit. Right? Radius r is equal to capital R plus h. That is the orbital, means orbital radius from here to here it is. This is h, this is r. R plus h is equal to radius of the orbital. How much time it will take to complete one revolution or one circle around the earth here? That is very important. Look at here. Satellite revolving around the earth in circular motion, uniform circular motion. We are describing or we are detailing explaining here about the circular motion of the satellite around the earth. That means what is our area of circle here? Area of circle is what? 2 pi r. Right? So that is 2 pi r we will consider. As the satellite is moving with the velocity, orbital velocity v0 here, right, with a certain height, right? Instead of saying height, we will inform here with the above the surface of the earth. It is executing the uniform circular motion around the earth with the radius of the earth capital R, whose mass is m here, and the orbital radius is r plus h. Right? When it is executing this much function, taking the uniform circular motion around the earth with the orbital velocity, that is circumference of the circle here. Circumference, you know, at the end part of it is, right? As from the center to the circumference of the earth or the circumference of the orbit, that is nothing but the radius of the orbit here. That we know, right? As time tells here, circumference, because it is taking the uniform circular motion, circumference of the circle, right? And the orbital velocity. So directly I should not write here orbital velocity. Orbital velocity. This is called as this is a form of time period of the your satellite. As when satellite is taking revolution around the earth with the orbital velocity. So you should remember here orbital velocity means we have calculated, we have expressed what will be the form of orbital velocity, right? So with the velocity, it is moving in horizontal direction and going to the final point of the path where it is started. That is nothing but the uniform circular motion. Means This is nothing but the circumference of the circle here. That is 2 pi r. With the velocity what? Orbital velocity. That is circumference of the circle by the orbital velocity here. So t is equal to how much it is? T is equal to how much? 2 pi r divided by v naught here. V naught means what? Orbital velocity. So what is this v naught here? V naught is nothing but g root of gm by r here, right? So what is this? This is the orbital velocity. This is also we have already discussed in the previous class. Those who did not understood, go to the back of it, realizing, understood, and then come to the exact point here, right? Now we will get this is the orbital velocity. Find out what will be happening here. 2 pi r, okay, root of gm by, I'll write once again, root of denominator to numerator, that is 2 pi r. Then what it will happen here? Root r by gm it will happen, right? Now what will be the next form? 2 pi r, right? So here in terms of root r, I will take it here root 1 by 2 by root of gm. I will explain how I have taken. Root r can also be written as r raised to 1 by 2 here, right? Now for that reason, instead of writing root r here, I have taken out the root. We can also write it root r is equal to r raised to 1 by 2. So r raised to 1 by 2 divided by root gm. Root I have not taken out the gm out. So gm will be remains as in the root only, root gm. Now what it will happen? See the two bases of r. This is what? Radius of the circle, where the satellite has to be taken circular motion around the earth. Where this r is what? Radius of your orbit there, where it has to execute the circular motion around the earth. Now both are the same basis here. Now what will be the power of their same basis? Let us consider one small example here. If a raised to m and a raised to n is there, bases are same, then their powers can be written as a raised to m plus n. Similarly, here r is there, r raised to 1 by 2 is there. Now what it will happen? 1 plus 1 by 2. What is the final here? R raised to 2 into 1, that is 3. I need to say that 2 into 1. LCM, take down 2 plus 1. 3 by 2. Now I will write it here directly. T is equal to 2 pi r cube divided by root m here, right? Root 3 by 2 here. R raised to 3 by 2. Now root r is equal to r raised to 3 by 2 can also be written as, look at here, r raised to 3 by 2 can also be written as root of r cube. Once again cross check. Root r can also be written in the form of 1 by 2 means, right? So r of 3 by 2 can also be written as root 1 by 2 will be in the form of root. So r raised to 3. Can I write it or not? Yes. Similarly, same form I am writing here. 2 pi root of r cube by n. Right? So 2 pi root of r cube by gm. So this will give you time period of the satellite. As we know here, r is equal to what? Capital R plus h. What is this capital R? Radius of the earth. H means what? That is the height or the above the surface of the earth where satellite has to execute the uniform circular motion around the earth here. Then when you place it here, what will we get here? 2 pi root of r plus h whole cube, right? Divided by gm here. So this is also called as a time period of the satellite. So what it tells, how much time it will take to complete the one revolution around the earth is what? T is equal to 2 pi root of r plus h whole cube divided by gm. If this satellite is very much nearer to the earth, so if it is height is there here, as it is showing the very nearer to the earth. At that time what it will happen? H will be very smaller to the R. Almost compared to the radius of the earth. At that time what it will happen? At the position where the satellite is very nearer to the earth. So almost its height is compared to the radius of the earth, means height will be neglected. At that time what it will happen? The time period of the satellite. So as we got it here, height will be neglected. When it is very nearer to the earth surface. Almost it is compared to the radius of the earth. Very near. Height is very nearer to the, or it is compared to the radius of the earth. At that time, T will be, or height will be neglected. So what is that? 2 pi, right? So R cube divided by Gm. Now look at here. Gm means what again? As we compare the acceleration due to gravity on the surface of the earth, G is equal to Gm by R square it is, right? As a G R square is equal to Gm, right? In place of Gm, if you place it here, what you will get? What you will get here? Let us cross check. 2 pi, right? So R cube divided by Gr square, right? Here R and R will get cancelled. What is remained here? R by G. This is the time period of satellite when it is a very nearer to the earth surface, or else we can say that almost it is nearer to the earth, or a radius of the earth compared to radius of the earth. Satellite is very nearer. At that time height will be neglected. Then what it will happen in the time period of the satellite here? 2 pi root of R cube by Gm. Gm, what is that? Standard one it is. G is a gravitational constant, M is the mass of the earth. As acceleration due to gravity on the surface of the earth, we know that G is equal to Gm by R square. Then Gr square is equal to Gm. In place of Gm in the time period of the satellite, if you substitute, what you will get here? T is equal to 2 pi root of R cube by Gr square. Here R and R square will get cancelled. What is remained here? T is equal to 2 pi of root of R by G it is. This is the time period of the satellite when it is very nearer to the, compared to the radius of the earth it is. Right? If you square this one, squaring on both the sides. So just squaring on both the sides means LHS and RHS. So what you will get here? You will get T square, right? 4 pi square. Then what you will get here? R by G. Or else we can say, instead of taking root of R cube by Gm, directly I will take this form here, where we have written. So T is equal to 2 pi R cube by Gm. This is the standard time period of the satellite. No, squaring on both the sides here. Now what you will get? T square, 4 square, right? I will write it here. Square will be removing. So what is remaining here? 4 pi square R cube by Gm, right? So T square. So look at here. 4 pi square is a standard one. I mean to say that it is a constant. G is a constant. M is constant. Which is variable here? R. R is variable. As R is changes, then time period of the satellite is also changes here. That means directly square of the time period of the satellite. Square of the time period of the satellite is directly proportional to the cube of the orbital radius, or a radius of the orbit. So this is nothing but the Kepler's second law of the planetary motion that we are going to discuss in the upcoming part. This is also called as a Kepler's law of planetary motion. Kepler's second law of planetary motion. That also we will discuss in the upcoming topic then, right? This is about the time period of the satellite. So how much time it will take to complete the revolution, I mean one revolution around the earth. So time taken by the satellite to complete one revolution around the earth, that is nothing but the square of the time period is directly proportional to the cube of the radius of the orbit. So these all things are derived here, how much it is varying, acceleration due to gravity on the surface of the earth. So how the time period it is, that is due to the uniform motion. We have taken the circumference of the circle because it is in the circular motion. Uniform circular means continuously on the uniform circular way. Circulation is taking place with the orbital velocity. That's why we have taken circumference of the circle by the orbital velocity. Then we all have whatever the data we have or whatever the steps we have taken, this is all based on the our discussion only, right? So this is about the time period of the satellite. Totally we have discussed what is satellite, types of satellites, energy of the satellite, time period of the satellites. Based on this, they may ask very important questions in your competitive also, because very shortcut also directly the relation between also we have discussed in the previous class, right? Now we have discussed launching of satellites, how many stages will be there, what is the each stage function, that also we have discussed. How the energy will gain by the satellite, that also we have discussed here, because of centripetal force. Kinetic energy will be there for the satellite, and potential energy due to the gravitational force which is acting on the body by the earth, that is also we have discussed. So finally we will get how much time we will get to complete the satellite to revolve around the earth. So next it is very important, that is geostationary satellite, that we are going to discuss there. So now we'll take on to the next part, that is geostationary satellite. We'll just study what is geostationary satellite, what are its importance, and what are the uses of it. Geostationary satellite is again one of the satellite which we seems to be as a stationary when we observe from the earth here. So that is geostationary satellite is a satellite which is said to be stationary when we observe from the earth. Now look at here, its motion is synchronized with the rotational motion of the earth. That means the geostationary satellite is, its motion is synchronized or it is matched with the rotational motion of the earth. How the earth is rotating around the sun. Same way, this geostationary satellite is the one which is moving around the earth, which is same, means both are same, synchronizes, matches with each other. How the rotational motion taking place, the earth around the sun. Similarly, same rotational motion or around the earth, it is matched with the how the earth in the rotational motion takes place around the sun. Similarly, the geostationary satellite, which seems to be stationary, means it seems to be stationary when we observe from the earth here, but it is not stationary. It is showing its rotational motion, which is matches with the how the earth is taking the rotation around the sun. Same way, the direction of motion of the satellite is the same as that of the earth. How the rotational motion or the in which direction of earth is taking the rotation. So now it is written west to east. So it is moving, earth is moving from west to east. Similarly, the geostationary satellite, that is also taking in which direction? The direction in which the earth is taking revolution around the sun. That is the direction of motion of the satellite, same as that of the direction of motion of the earth around the sun. It is from west to east. Then axis of rotation of the satellite is the same as that of the earth. In which axis of rotation? In which axis of earth is rotating around the sun? Same axis of rotation. In the same axis of rotation only, that is geostationary satellite is taking the rotation there. That is same axis it is. Then its time period is equal to the rotational period of the earth. See how much time it will take the earth to complete one time period or time period of rotational motion of the earth. Same time period of the satellite takes place here. The one day means it is a 24 hours. So time taken by the earth to complete right rotation on its own axis. So that is same as the time period of geostationary satellite. So time period is also same, axis of rotation is also same, the direction of motion of geostationary satellite as we compared with the rotation of earth is also same. So that is means it seems to be one of the satellite where it is seems to be stationary when we observe from the earth, because it is taking on same rotation, and because it is taking the same rotation, its time period is equal to the rotational motion of the earth. That is 24 hours. See, look at here, the satellite which is taking the revolution around the earth, where the radius of the earth is a capital R and h is a certain height. I mean to say that above the surface of the earth, where it is executing the revolving around the earth, that time period is equal to the rotational motion of the earth around the sun. So it is almost equal to each other. Time period is also equal to each other, synchronizes. The word we are saying that it is matches instead of matches. We are saying here synchronizes. So that's why it is also called as a geosynchronized satellite also, or a geostationary also. Time period is matches with the time period of the earth, and direction of rotational motion of the earth is also matches with the direction of rotational motion of the geostationary satellite. So time period is matches, direction is matches, rotation of its motions is also matches here, axis of rotation is also matches. So all the points which is matches to each other, that's why it is called as a geostationary or a geosynchronous satellite here. So it will be very vast application here. It is very helpful in broadcasting or telecasting the TV programs here, or weather forecasting. So we will get the very much uses of this geostationary satellite, because it will give the entire shape of the earth here. So that is very important thing. Most probably this geostationary satellite will use for broadcast, telecasting the TV programs, radio programs, and any other kind of the finding the weather structures, climate changes. All these things will be studied with the help of this geostationary satellite here. So there must be a condition of geostationary satellite. That is only whatever the things we have studied here, these are one of the conditions also. That means motion of the geostationary satellite should be matches with the rotational motion of the earth. This is also one of the condition. It is also a condition, and it is a functioning also. So direction of motion of satellite must be equal to the or matches with the rotational motion of the earth around the sun here. That is west to east. Similarly, the axis of rotation of satellite must be equal or must be same as that of the rotation of earth. As the time period of geostationary satellite must be equal to the time period of the earth, which is around its own axis, that is 24 hours. It should be matches. Then only it is said to be as it is a geostationary satellite. This is also called as a geosynchronized communication satellite. Here the shortcut we will write it here: synchronized satellite. Here this is the uses synchronized communication satellite. For which purpose it is said here? This is a very important point. They will use it from this geostationary satellite, that is synchronizes communication satellite. It's helpful in programming the TV or telecasting the TV programs, telecasting the radio programs, and checking the weather forecasting. That's why it is set as a, instead of geostationary satellite, this said as synchronized communication satellite. What is that? Synchronized communication. So which purpose it is using? For that purpose only it is said as communication satellite. It is short form mean they have given synchronized communication satellite. So what are the satellites are there? INSAT 2 is there, INSAT 3B is there, INSAT 3B, INSAT 2C. These are the synchronous communication satellite of India. These are the very important synchronized satellite of communication satellite of our India. That is nothing but the geostationary satellite. That is INSAT 3, INSAT 3B, INSAT 2C. These are the geostationary satellite. Now comes the point here, polar satellite. What is this polar satellite? Same way as we said here, the satellite which is moving in a closed orbit, that is also called as a parking orbit. It is for the geostationary satellite. Similarly, the one more satellite, that is polar satellite, that is moving on the that is one axis which is perpendicular perpendicular to the direction of the equatorial plane. Now point comes here, what is equatorial plane? See here, if you consider this is a axis of rotation here. So the whole part, whatever we are seeing, no, this is a equatorial plane, equatorial or equatorial. So this is a equatorial plane it is. So as we know here, if you consider as it is one of the earth here, right? So once we consider this is the one part of the rotation here. So this part is called as equatorial plane, right? This part, only this part is equatorial, right? As the body is moving or satellite is moving on the axis of rotation here, that is equal to the rotation of the earth. As we said, that is a condition of the geostationary satellite, which will be same as that of the rotation of the earth and same as that of the direction of rotation of the earth, and time period is also same as that of the earth. That's how much it is taking. Similarly, it is concentric coplanar axis it is. So geostationary satellite should be move in a parking orbit. I mean to say move in a closed orbit. That is called as a parking orbit. Parking orbit means again which satellite is moving on concentric coplanar of the equatorial plane it is. So this is concentric coplanar. So with the help concentrating, which is concentrating here for the satellite, earth is a concentric and coplanar with the equatorial plane. So this part it is called as the on which direction or in which part of the geostationary satellite is revolving. In this axis it is rotation. It should be compulsory. It is one of the condition of the geostationary satellite it is. That is, it should be the satellite which is revolving around the earth, that should be concentric and coplanar with the equatorial plane. That is one more satellite, that is polar satellite. That what it will do, it will move in the direction perpendicular to the equatorial plane it is. So it will be in this direction. So body is or satellite will move in this direction. Here in geostationary, body will move in this direction. So this will play the role of geostationary orbit or equatorial orbit it is. Equatorial orbit. Right. So this is of geostationary orbit it is in this direction. Right. So this is very helpful in telecasting the TV programs, radio programs. So purposely it is communication satellite it is. That's why it is called as a synchronized communication satellite. Which is it is geostationary satellite. So conditions are there. It should be in a concentric coplanar with the earth it is. Concentric coplanar. It is moving around in this axis of rotation. That's why earth is revolving around its own axis, that is 24 hours. Similarly, so it is also having the same period. So that's why it seems to be as a stationary when we observe from the earth. Similarly, one more satellite, that is a polar satellite. So that is moving, that is also moving in a fixed orbit, closed and a fixed orbit, but which is perpendicular to the equatorial plane. Which is equatorial plane here? This is equatorial plane. So which will be in a perpendicular. So the satellite is moving in this direction. So it will tell you, polar satellite will tell you exactly on which portion of the earth. So it will give the exact portion. Means if you want this portion or a Delhi or a Dharwad, whatever it is, in that particular position, what will be the climate or what will be the entire area of that portion. So that will observe, that will studied by us with the help of this polar satellite, that is perpendicular to the equatorial plane. It will go for the particular area, it will go for the particular portion in a, with respect to or in a one particular local diameters. That is the uses of polar satellite. So what is the use of geostationary? That is the uses of telecasting the TV programs, radio programs, and finding the forecast, weathering there. This is exactly on which direction it is rotation of earth, that is concentric coplanar of the equatorial plane here. But polar satellite is in which direction? Which is perpendicular to the equatorial plane. So that will tell you in a particular area, that will tells the entire surface of the earth, or where is, what is happening in particular portion of the earth, how the floods are coming, how much it is lost, where is the loss is there, or where the particular earthquake, or we can see that where is the particular portion, where is the product is there, so that we can observe from the polar satellite particular portion. So when we want to focus with Harvard area, when we want to focus with Delhi area, so what is that function, what is going on that particular area, what is harm in that, what is good in that, everything we are going to study with the help of polar satellite, because it will give you entire surface of the earth. If you focus on particular area also, it will be very helpful result we will get from the polar satellite. That is the use of polar satellite as compared with the geostationary satellite. So they have their particular orbit which is compared with the your equatorial and equatorial plane of the earth. So geostationary will be very much useful for communication satellite. That's why it is called as a synchro communication satellite. As we go for the polar satellite, it will be useful for the other purposes like particular portion, what will be the function is going on particular area, and if you want to study the entire surface of the earth with the help of this polar satellite. This is the very useful or helpful from the satellite what we are now. Polar satellite is a spy satellite because of it is synchronizes, or it will be geographically moving in a particular portion from north to south it does. That's why it is called as a space satellite. It will be very useful for weather forecasting and land survey, land and sea structure. We want to record the land part of it, we want to record the river and monitoring the population. So these are all the things we will discuss, or we will take the help of polar satellite. So as we have the IRS satellite, IRS, we go with the IRS A1, IRS of 1B. So like that many are there for the polar satellite that will be useful for our study the surface of the earth here. So next comes here weightlessness of the body. So once a man is standing on the surface of the earth, as we definitely feel it as it is a weight is there, because what is weight? Mass of the body which is accelerating or it is directed towards the center. If the satellite, in that satellite one person is there, if both the bodies, means satellite and the person who was there in the satellite, right, both are under the pressure or under the force which is attracting towards the earth here. So once a satellite is there, that is under the gravitational force, right? If in that satellite the person is there, so particular portion, see, one body is or one person is there on the surface of the earth, means that body also executes the force on earth and earth also executes the force on body. Action and reaction forces are taking place. That's why both are attracting to each other, right? Similarly, earth will attract the body and body will attract the earth. Action, reaction takes place when the body is there on the surface of the earth. Similarly, if a body, what we have considered body, that is nothing but the satellite, if we consider that is satellite, that is away from or above the surface of the earth. So that is also takes place. Satellite also attract the earth here, earth is also attracts the satellite. So they are in the action and reaction process. If in that satellite one person is there or one human being is there, so human being and satellite, in between them there is no action and reaction, because satellite does not attract the body which is there inside or which is on the surface of the satellite. Similarly, the body which is inside or the person who is inside the satellite or away on the surface of the satellite, there is no action and reaction takes place. So there is no force between the satellite and the person which is already in the satellite. Similarly, satellite and the person who are there in the satellite, both the bodies are under the force of gravitational here. So both will become action for earth and earth will become a reaction for satellite. In that satellite person is there, the same force will be there. So similarly, for that action, there is no process of the person who is stand properly on the satellite there. The body or the person who is properly taking a function on the surface, means there is action and reaction process takes place, or force is there in between, so it is felt as a weight. The body or the person who feel it as it is a weight. We are having weight there. One person is there in the satellite, so there is no action and reaction takes place. There is no force between the satellite and the person who are there in the satellite, so definitely they won't feel weight there. So they will feel it as a weightlessness. They will float there in the satellite because of loss of force between them. So if force is there between the two bodies, they can exist or they can stand properly. They feel it as it is a weight is there, existence is there. If there is no force between the bodies in the same particular area, then there is no weight it is. Similarly, we can discuss the person who are there in the satellite. So satellite and the person who are already there in the satellite, there is no force between them because no attraction force is there. There is no action and reaction process takes place. So they will feel it as the person who are there in the satellite, they will feel it as it is a weightlessness. They will not stand properly on the satellite. You have observed in the many of the videos or many of the news there, they will feel it as a weightlessness. They were floating there. They can't stand properly as we are standing on the surface of the earth. This is the difference between the person who can do anything on the surface of the earth because action and reaction takes place. Force is there, force of attraction is there. So we can doing many things here. Same things what we are doing on the surface of the earth here, we can't do on the space or that too in the satellite here. Though they will feel it as it is a weightlessness. This is the concept what we are going to discuss, that is weightlessness. And we have, I think, got clarified about the geostationary satellite and polar satellite. These are the very important satellite. They will give you entire structure and they will give you land and sea and finding the river, measuring the rivers there, on monitoring the population and telecasting the TV programs, radio programs, all the communications programs, and these all things will be discussed based on or we will study based on that these satellites. This is very important part as we discussed here, and they will ask you the short form of synchronous view, the entire surface of the earth. That will, it is very useful in studying the climate of a particular area, and it will give the particular portion of the area in a local time, in short intervals of time, in the same time, that will search in the different directions of the or different directions of surface of the area, that will give the entire section what is going on Harvard or what is going on Delhi. At the same time it will give the informations to how the climate will be there in the other part of the surface of the earth, how we have to face it. These all things guidance also it will give, and it will give the informations. So very much useful of the satellite here. This is what we have wanted to discuss. If you more information you want, you can just go ahead with the URL NCERT textbook. They have given a plenty of information there. I think I have tried my level best to convince the geostationary satellite and polar satellite. Hope you understood. Thank you.